Hello, Evan Smith, Idaho State University College of Technology. Today we'd like to talk about infrared, and so let's just look at a few of the things that are related to infrared energy and light, if you want to think of it that way. First of all, there's a video here put on by FLIR, and I'd just like to ask that you pause right now and go view that video. It'd be worth your time to just kind of as an overview of what we're going to be talking about. And after you've had a chance to do that, come back and we'll talk about some of the highlights. Should be back. Infrared has several concepts. Part of the electromagnetic spectrum, as we saw in the video, behaves very similar to light. It can be reflected, can be refracted, absorbed, emitted. There's also a concept of reflectivity plus transmissivity plus emissivity is going to be equal to 1. In other words, how much is reflected, how much is sent through the material, and there's also this concept of emissivity, which essentially is how much can be absorbed through the object itself. Emissivity has a few different definition sources. If you want to think about it, I think the main one is the ratio of radiation emitted by a surface or black body and its theoretical radiation predicted from Planck's law right there, if you want to get really technical. Key concepts: high emissivity is a scale of, actually let me back up, emissivity is on a scale of 1 to 0. High emissivity means that the total energy is emitted. There's no reflectivity of surrounding heat radiation. In other words, whatever energy is there, it's going to be just seen with the object if you're looking at through an infrared camera, as we'll see here in a few minutes. And then there's another definition right there of what emissivity is: the ratio of radiant energy emitted by a surface to that emitted by a black body at some temperature. Emissivity can be one of the harder concepts to grasp hold of, but I think it's fairly simple too once we get an idea of what's happening there. It's the ratio of actual amount of electromagnetic radiation emitted to the amount emitted to an ideal black body, and that's essentially what we kind of just mentioned one or the other. One of the key parts is color does not affect emissivity. In other words, if you have a white spray paint and a black spray paint, emissivity is not going to be affected through that. But it may affect the absorption of visible light. So in other words, when you have a black car or a white car, the black car will get warmer inside, but that's because it's the entire spectrum that will be seen through the light energy that's coming from the sun. It has a lot higher, what we'll see really, if you think about it, the sun is being able to take the entire visible light up through the entire infrared spectrum there, and the sun is working that direction. But when we're looking with just the infrared cameras and so forth, we're only going to be seeing this part of it. Yet as it gets out, the sun and so forth can be operating in that, which will bring in some of the light energy that's affected with that. A black body is a perfect absorber and emitter of radiation. In other words, if you have a pure black body, whatever radiation or whatever light hits it, it's not going to be reflecting any of that light out. It will absorb everything. Excuse me. It will absorb everything that is there. All light energy is going to be taken into it. It's hard to create a pure black body when all is said and done. And here's some of the infrared, that wavelength we just saw here a second ago. Looking at it from a little different, we've got our visible light, which is right there, and then we've got this full infrared and shortwave, which is essentially what you can see with cameras that they're able to build cameras with, and there's some other infrared wavelengths that are getting in there. If you think of light, light is essentially a wavelength, an energy wave going on, and you can see here that down into the X-ray side, the waves are really short, and so forth. And as you move up the spectrum, we have the ultraviolet there. Visible light is going to be right in this range. And then as the waves get longer and longer, we go into the infrared, up into the microwave, and then into radio waves. And it's interesting, if you think about it, the radio waves have very long wavelengths, so they're able to actually go through the concrete and other building materials, and so we can actually pick up radio waves that are out there, along with some of the others. But some of the visible light does not. The wavelength is short enough; it will not go through there, and part of that's due to the material also. As we just saw, infrared is part of the electromagnetic spectrum. Radiation is categorized by wavelength or frequency. Unit of measurement used in the micrometer or micron is micrometers. 1 micrometer is 1 millimeter for a wavelength. And radio stations are identified by their frequency, usually in kilohertz or megahertz. Infrared detectors or systems are categorized by their wavelength. All objects emit infrared radiation. A little bit of information there, but some of that's kind of for trivia's sakes also. But the key thought is all objects are emitting infrared radiation as a function of their temperature. In other words, the cold objects are not going to emit as much. Real hot objects are going to be emitting a lot of radiation, or infrared radiation. Okay, we just glanced at this wavelength a second ago, but again, just kind of a review of where we're looking at from the infrared spectrum. And here we're looking at infrared for what we are able to see with our cameras that have been built through the different companies. And again, just a little bit, the cameras are going to be working on this short wave. They've got two different kinds that are essentially manufactured. There's those that can see the short wave, and those that are actually looking at the long wave. And they're both within here, but a little bit of technical. We'll let you look up the camera specifics if you'd like to see what's happening there. Most of them now are working off the long wave because it doesn't take a reference cooler and so forth to deal with that. And here's what we're actually seeing. We've got this light energy that's coming out. We can see between here and there, or essentially our eyes, visible light, we're physically able to see between this spectrum range right in here. The sun is going to be emitting pretty much all of this when you get right down to it. The infrared spectrum for the shortwave cameras that are going to be able to see here, and then we also have the long wave, which are right in there. When you look through an infrared camera, you're going to be seeing, here's some sample images. Let me just word it that way. If you look at this, you can see that we got a coffee cup or a cup with hot tea or some kind of a hot drink. You're going to be able to see that there actually is something happening in there, that there's some warm temperatures. The handle's going to be cooler. In this case, you can look over here and see that the red and the yellow is hot. Then it gets down here to the black and violets that are going to have less temperature. That's just the scale that's shown on the camera as it comes in. And you can also see, and that's an interesting one right there where you see the spoon. It's right there on that tip right there. It's probably not actually that hot. When you look at this scale, it's probably not actually up into the 115. It looks like somebody just took a hot tongue and licked only half of it. What's happening is a shiny spoon has low emissivity, and so it's probably reflecting the heat off of this cup. And hopefully that's kind of a precursor to what's going on with emissivity. Here we have a tank. You can see that it's got a colder fluid in it, and it's only that full. Infrared's kind of interesting. You can actually use it to see levels, tank levels and so forth, what's happening in sort of medical industry. They can use infrared to actually see blood flow in the veins. Infrared can be a valuable tool for military and different aspects. Here it's kind of interesting. You can actually see the exhaust pipe for this tank, military tank, as it's coming out of there. You can see the little muffler system and coming out through there. And I believe this is not external to the tank, but I won't swear to it. I think it actually does have a cover on it. Jet fighter, looking at some of the different infrared spectrums. And oops, get back here. Infrared cameras don't capture visible light. They capture electromagnetic radiation of 1 micrometer to 1 millimeter. And so if you see a picture such as that, infrared cameras are not night vision. This is one where it's actually a night vision. The only thing a night vision camera does is it enhances visible light back on the other back on that part of the spectrum is the word I'm after. And if you have a cell phone that claims to have infrared, it's probably just a color rendition that's going in there. A good test you can see if your cell phone really did have it is, can you see a handprint on a higher temperature emissivity object? Is what that's trying to. In other words, put your hand on a table or a wall that has a fairly good emissivity on it, and take your hand away, and you can see if your handprint is still showing. Then it probably is an actual infrared camera. They do make infrared adapters that do fit cell phone camera or cell phones now, so they're kind of a fascinating technology when you get right down to it. Just kind of as a tidbit, back when I started doing infrared, they had a small, you had to carry around essentially refrigerator tanks with you. And when I say actually tanks of argon, and so as the gas coming out of a compressed argon tank would expand, it would make a colder temperature, and then the cameras could actually use a reference point to that camera. They worked for the time and day. This would be back in the 1980s. They worked well to go out and do some maintenance work with them, to look for hot spots and so forth, and as a maintenance function is what we were doing with them. Today, it doesn't even take the cooler. You can turn them on. They're functional within a minute or within a few seconds, and now they've even got them down small enough where you can find an adapter that fits to a cell phone. There's some infrared properties. Kirchhoff's radiation law quantifies that the total energy is going to be equal to three different concepts: emissivity, reflectivity, and transmissivity. We already saw that a little bit. And if you think of opaque objects, transmissivity is going to be equal to 0, and then emissivity plus reflectivity is going to be equal to 1. So these essentially, think of it as a percentage of how much is going through. And so typically you don't have to be looking at transmissivity if you were using infrared as a maintenance tool or as an object to see things. Again, we're looking at some of the thermodynamic concepts, but infrared is one of those that's talking about heat, so I thought it'd be worth bring this into the course at this time. Here's some images, shiny metal, and you can see they've put a piece of black electrical tape. The center cup is at room temperature. And this cup over here has cold fluid. This one has hot fluid in it. And what's happening with the black electrical tape right down the center of it, electrical tape has a emissivity of about 0.95 thereabouts. And so if you put it on an object, that will be giving you a fairly true temperature or accurate temperature for what you're actually looking at with the infrared camera. In this case, you can see the hot cup. It's got some shiny metal, so it's got some very low emissivity. It's getting some reflection from the background, and so you can look at the tape right here, and you can see that it's an actual temperature that's happening. If you come over to the cup and everything that's at room temperature, you notice you can't even see the black tape, and the only place you can see almost anything is where the cold is reflecting off this side and the hot is reflecting off that side of the cup. Otherwise, you couldn't even see the object there because it's at the same temperature as the background temperature. And here we got the cold, where you can actually see the total temperature. There's a little bit of heat transferring in, which makes the surface colder than the rest of the side, or there's a little bit of heat transferring out, which makes this cup just a little bit hotter. You can tell it's probably insulated a little bit and so forth. In general, dielectrics, electrically non-conducting materials, have high emissivity ranging 0.5. Metals are typically lower range, and polished and clean surfaces really get down to low emissivity, which means it's going to be harder to see with a camera if you're using infrared cameras, and it's going to and when I say see it with the camera, what I'm saying is they do have infrared sensors that don't convert into visible light, because that's all that's going on with the camera too, is you're transferring that infrared energy or infrared light, if you want to look at it that way, into a visible light, and they're using the electronics to actually make that transformation for us by looking through one light sensor or electromagnetic wave sensor into something we can actually see. I don't know, rambled a little bit there, but hopefully it makes sense. There's just some emissivity ratings. Again, cold rolled steel is going to be fairly visible because it's got that film coating or steel coating on it, and then you get down to the mild liquid and so forth, and you just see that polished is going to be, you can only see about 10% of the light that's coming through it, and so it's hard to actually visibly see due to the background reflecting off of it. And there's just some other emissivity values. If you'd like to pause and look at some of the concepts there, it's kind of interesting just to see what infrared camera is going to do for you. Again, a few more of the different items that are out there. And you'll notice, I believe, maybe paint's not on here, but if you get paint, you'll notice that they have a fairly consistent emissivity, as I already mentioned earlier, that a black paint will have the same emissivity as a white paint. It's just so they will look, you'll see the same temperature, assuming there isn't any light energy or sun energy coming from a different level of the spectrum coming into it. In thermography, infrared thermography, it's a good maintenance tool. You can actually see electrical connections. When the electrical connection gets loose, it starts to get some resistance through that connection, and which will generate heat. And so you can start seeing these the heat that's starting to be generated a little bit more than the other one. We'll see a couple images of that. So it's an excellent maintenance tool to go out and see the connections on your electrical equipment and actually know that they're about to start. They're starting to get loose. They haven't failed yet, but they're getting close to it. So you can scan the equipment with your infrared, see that there's a connection getting loose, shut the electrical source off, go in, clean up and retighten that connection, put it back, and it doesn't turn into continuing to get loose until it arcs across and explodes the connection that's going into it. I've had a lot of serious injuries through that over the days, and the infrared inspection has really put a good source of correcting that. A good source to see with a heat exchanger, how it's working across the process, across the exchanger itself. If you've got a chemical or process equipment that's using heat, it's a good way to see if things are flowing like they should, so forth and so on. And military and law enforcement, and well, I guess they've talked about using them for hunting, but I think in most states or a lot of places it's illegal to use it, so we won't talk about it. There's also what can the camera actually see, and this is one of the spot size ratio. If you think about it, you've got this source here, and you've got the infrared coming out, and it's just like our visible light. We can put our finger right in front of our eyes, and we see just, there. If you keep looking, out, our eyes are going to be seeing a full, it's going to, our range of view, if you want to think about it. So there's what we call this spot size ratio. But what is that really when we're looking at spot size? If you think about the spot size, we're looking right here, and our eyes can be seen. We're going to be coming out here, and what they're trying to show here is if we've got an object that, we're looking at an object that our eyes is totally within the range of our eyesight, we're going to be seeing 100% of that energy. Yet when we come out here, if we've got a camera that's looking, like this, then our essentially what's going to happen is we're going to be picking up. Oh, that's not explaining it very well, probably. Let me see if I can get this corrected. Essentially what it's saying is, as we have our visible light, if we're trying to look at the temperature of an object right there, well, it's just like a camera. That camera is going to be having that cone of visibility, which means, if you're coming across like that, then we want to know the temperature of just that object right there. The camera is just like our eyes would be seeing a lot more than what we've really got. It'd be actually picking up this colder temperature all around it. And with the way a camera works, if you think about it, it's got this array right here. We've got our hot spot right in the center. We've got a hot spot right there, and the camera's actually going to be picking up. What they do is they have these thermal cells, or cells that pick up the light and so forth, tuned in for the infrared thing. But the camera's going to be taking these up, and this small part, and it's going to take an average of all the temperatures that are being picked up by that cell. So in other words, if this is 1,000 degrees and the background's 100 degrees, well, you're probably only going to be seeing it's probably going to give you a temperature back on your reading on the camera itself of maybe 101 or something like that, if that's only 1% or 100. So even though you've got a really hot object, if you're too far away from it, it won't read. It's going to be taking the average. And what I'm saying here, think of that as the array that is being used. That the camera's actually picking the light up, just like, hopefully that makes sense, that the little pixels that are being pulled in and taking the temperature off that one little part is actually going to be what's recorded, which means if you can actually bring your camera up close enough and you're looking at it like that, everything on the camera is going to be visibly, you can actually see, not visibly, but actually the camera will pick up the entire object, and so you do have full temperature. So you got to be careful with that. If you're too far away, you can see the hot object in the camera. The hot object will show up, but if it's got that averaging temperature like most of them do, it won't be the accurate temperature, but you will be able to notice that there is a hot object in there. So yes, it's good, but don't totally trust the temperature it's telling you it is if there's a lot of background temperature also being seen by the camera. And I guess one thing to keep in mind is a lot of times our minds think of infrared because we're used to this laser that's coming across, and the laser does keep that light focused right on there, and sometimes there's even a sight thing on those handheld infrared temperature sensors. That laser's going to come out, it's going to be touching that point, but yet the infrared spectrum that the camera's picking up is still going to be that full length that's in there. Looks like with time I better keep moving. If the only thing that is important is a temperature compared to other things, then the true temperature may not be accurate, but it will give you a good reading. There's just some different infrared images. In this case, they've got a jet fighter, or that's not a jet fighter, an airplane. You can actually use infrared to see if there's leaks or the shell is starting to get loose, and it will actually let some moisture into it. As the moisture gets in, it gets a little cooler or transmits the heat a little bit better. You can actually use an infrared camera to come in and see which rivets or which fasteners are starting to get loose, is there a leak. Of course, you can use it for a house and see where all the heat leaks are. And you can see that the roof has some pretty good heat coming out of the top of that. A couple weather sources. You can see the hunter actually trying to shoot at night when he's not supposed to. I don't know what the image is, but here's a guy getting arrested with his police dog. Boats out there, hijackers of a boat, drug cartel, whatever they are, trying to get things on. And of course you got the sniper in the shows that get into it. In the camera itself, they use some color ones, or some black and white, and color is really just there for the viewer to be able to see when you got a camera is putting out color. It just helps look at some of that's going on. But in reality, when you look at it, you almost get better definition, black and white, once you get used to looking at it. But color is being converted within the camera itself. And so that's just a function to help us in our visible perspective. The infrared does not see or distinguish between different colors. Again, there's different uses for the infrared. The space shuttle coming down with the hot tiles. This guy getting, better not say gas coming up. But anyway, just seeing that the spine has more heat going to it and so forth. Electrical connections, excellent troubleshooter for electrical. You see this one hot connection. You've got three, on your three-phase power coming in. I think that's a three-phase. Anyway, you have one connection that's a lot hotter than the one right next to it, which means this one's got more energy being wasted or being sent out as heat. This one's transmitting the electricity better. Need to go in and look at that and make sure it's not getting too hot to the point that it's getting bad. Here you've got three connections. They're all relatively the same, other than the one wire in the background there's a little warm. Does that make sense? Just need to be looking at it from that perspective. And we won't talk too much about this, not for this course, but again, there's just some images on what to look at for when you want to maybe be thinking about your electrical connections. What are some of the parameters that need to be done? And if you like to scan that a little bit better, just put it on pause and do so. There's a few things on mechanical perspectives, and again, I'll say the same thing. Let's not take the time to go through and talk about each one at this time. Different images of the infrared. There's the visible image, and there's the actual, what we're seeing. And again, this is going into our fuse there, where it's, at least I believe that's a fuse connection. Hot connection here compared to these two over there. So this three-phase power, this phase is having a little bit more heat being generated. And why is it being generated? You could also look at this, which is a 120 volt, probably a 120, low voltage wire transmitter, and you notice that this particular connection has some pretty good heat coming out of it. So is the thermal or the overload for that breaker happening at this time, or disconnect if it's not a breaker. But again, you can look at it and say, okay, wait a minute, our camera is reading white at 95 degrees Fahrenheit. Well, that may not be too bad for an electrical connection, and it might be that this is this one is generating out a fairly good load. This one may put some load, and the others may be totally off, nothing being generated. Nothing being used downstream on the power. So always keep in mind that the temperature of what you're looking at may be a factor in whether it's something you need to act on or not. Insulation in a home. You can see that we got good heat being transmitted out. This case, it's if you've got, and this would be on a colder outside temperature where the wall is nice and warm inside, but then all of a sudden you see these cold spots where the cold's actually, the heat's going out of the house faster up there because the moisture or the corner gets out. And so you can see that there's probably an issue coming up on that ceiling connection where it's good warm over here, good warm down there, but all of a sudden there's some cooler points going on in here. Good chance that our insulation is not work, or there's a defect, crack, or something of the sort right here in the wall. So anyway, just a good troubleshooting tool for that. You can also use it as a stud finder on a cold day. You can actually see where the studs are because they transmit the heat faster than not as good insulation. So you can use it as a stud finder if you want to get out for a good expensive stud finder. There's another application where you can see the water is leaked in and caused a little bit of a spot there. Roofs, they'll use them a lot. They'll use it infrared a lot for roof inspection. In the summer, the sun will heat the roof up and so forth. But if you've got a good air-conditioned building inside, just after the sun goes down, give it another hour or so, or a little bit more, and you can actually see where the roof is leaked, where the water is going to be coming through. It's going to be transmitting the heat's going to be going into the colder building, and you'll see where the insulation's working pretty good, but over here the insulation isn't as functional as it should be, so there could be a leak in that roof. There's just a couple of other applications. This one I found interesting because you can see where the framer or the insulator on the house ran out of insulation, decided not to put in that last foot. What does it matter, I'm just going to insulate. Well, you can see the studs there, but all of a sudden you see this big dark spot right up there, and it's nice and flat. Obviously, and by the way, this would be a wall. There's sheetrock and paint over the top. You cannot visibly see that, but yet the temperature, cold outside, warmer inside, you can see that it's transmitting the heat out quicker, and so you got a colder temperature right there. Call the framer or the insulator up and tell him you want your money back. There you can see a heat exchanger. You can kind of see the flow in it. This is probably where your baffle plates are, so you might get a little bit more heat transferred out. Another heat exchanger where you can see that it's coming in hot and you're getting some good cooling as it comes down. Here you can see that it's a valve through a ball valve, probably coming through a pipeline. Well, it's got good insulation there, hot fluid coming out that way. Doesn't need any attention. Well, probably not, because that temperature is fairly low when you look at what it actually is. It's just that it's warmer than the rest of it, and our camera's on the relative size. Hot bearing. Or is it? You look at your scale, 83, 84 degrees Fahrenheit. Well, that's not unusual for a bearing to be running that, so maybe nothing that you need to worry about, but it sure looks impressive when you take the image on it, so be careful with what the actual temperature is compared to the background temperature if you're doing any troubleshooting with it. Many applications, especially with heat exchanger analysis, you need to be thinking about what is the temperature you're trying to work with, and where you can also see a little bit of energy is going to be coming out a little bit out of sinusoidal, or not. It's just probably a square. I want to say squared function, but then again, you think T to the 4th power when you're talking some of the higher level infrared heat. So just keep that in mind. Or what is the actual power going on? And there's another slide if you'd like to pause and read through it, just talking about some of the different concepts that are in infrared analysis. And quick preview, just be able to know and understand what a black body, emissivity, reflectivity, and so forth. Humidity, we didn't talk a lot about it, but just remember you do have some cooling effect due to humidity, as the kind of like a cooling tower if you want to think about it. The humidity is higher on one's point. It's going to be transmitting heat out. Anyway, just think of the different concepts that are going in there. And so if you have any questions, go ahead and anyway, if you have any questions, let's just discuss them at our next class time, and for that we'll talk with you later. Thanks for listening.